Good morning, respected professor and everyone. My name is Jayesh Jain, and along with my team members Priyank, Drishti, Siddharth, Goutam, and Apoorva, we will be presenting this paper titled Challenges of Explaining the Behavior of Black Box AI Systems. This paper was published in MIS Quarterly Executive in 2020, and it addresses a question that is becoming more and more important in data science as well as decision science. Can we really trust AI systems if we don't understand how they make decisions? So, today we will explore how organizations can use powerful AI systems responsibly, even when those systems behave like black boxes. So, before we go into the technical framework, I just want to take a step back and think about how AI is evolving. Over the past decade, AI models, especially the deep learning systems, have become incredibly powerful. They can detect fraud, predict bankruptcy, classify images, and even generate text like this. But as models have become more accurate, they have also become more complex, and sometimes even the people who build them can't fully explain why a specific decision was made. That's what we call a black box AI system. We can see the input, we can see the output as well, but the reasoning in between is often unclear. Now, if we are using AI to recommend movies or optimize ads, maybe that's acceptable. But what if the AI is approving or rejecting a loan, flagging a company for fraud, predicting whether the someone is might default, or influencing public policy decisions? In these situations, accuracy alone is not enough. We also need fairness, accountability, transparency, and the ability to justify decisions. And this is where the connection to decision science becomes very important. Data science helps us build predictive models. Decision science asks how do these predictions translate into responsible decisions? The paper we are presenting today does not just try to open the black box technically. Instead, it asks a bigger question. How can organizations design and manage AI systems in a way that keeps them explainable and controllable? That shift from a technical explainability to organization explainability is really the core contribution of this paper. So, the question is, why has explainability become such a big issue? There are a few key reasons. First, there are legal requirements. For example, under the GDPR in Europe, individuals have the right to ask for an explanation if an automated system significantly affects them. Second, there are ethical concerns. We have seen real world examples where AI systems showed bias in hiring, in facial recognition, and in criminal risk prediction. Often the bias wasn't intentional, it came from the training data. Third, there's the issue of safety and reliability. If an AI system makes a mistake, organizations need to understand what went wrong. Without explainability, fixing these systems become difficult. And finally, there's trust. Especially in public sector contexts, citizens need to trust that automated decisions are fair and well governed. So, the big challenge the paper tries to address is how do we balance high performing black box AI systems with the need for transparency and accountability? And the rest of our presentation will show how the authors propose a practical framework to solve this. With that, I will hand it over to Drishti, who will explain how the authors break down an AI systems into six core elements and introduce the case study behind this research.
According to AI researchers Stuart Russell and Peter Norvig, an intelligent agent is a system that processes data, interacts with its environment, and works toward defined goals. To explain how such systems behave, especially when they seem like black boxes, we examine six key elements of an AI system. First is the model, the mathematical function that converts input into output. Some models, like decision trees, are easy to interpret. Others, like deep neural networks, are far more complex and are harder to explain. Second, the goals. What the system is optimized to achieve. If a model is designed purely for accuracy, it may unintentionally ignore fairness or balance. Third, the training data. The data used to teach the model. If this data is biased or incomplete, the AI will replicate those biases. Fourth, the input data. The real world data fed into the systems after deployment. Even a perfect model will reduce flawed results if the input data is poor. Fifth, the output data. The predictions or decisions the system makes, these should be reviewed, especially in high stakes contexts. Human oversight is essential. And finally, the environment. The real world setting in which the AI operates, if a system is deployed outside the environment it was trained for, its decisions may become unreliable. The key idea is simple. To explain an AI system's behavior, we must analyze all six elements together, not just the algorithm. Now let's briefly look at the Danish Business Authority case study, or the DBA, which operates under Denmark's Ministry of Industry and oversees around 800,000 companies. It runs the digital business portal where companies register, submit annual reports, and complete legal filings. Because of the massive volume of structured data, the DBA established a machine learning lab in 2017. Their goal was not to replace humans, but to act as a force multiplier, reducing manual workload while leaving complex judgment to human experts. What makes this case important is governance. AI prototypes are reviewed by a steering committee before deployment. External vendors implement them carefully. Transparency, documentation, and training are prioritized. This shows that black box AI system can be responsibly deployed as long as everything is perfectly aligned. Now my team member Priyank would give you an in-depth explanation about the Danish Business Authority case study.
Hello everyone. My name is Priyank Lal. I'd like to move from theory to a real world example. The case study here concerns the Danish Business Authority, or the DBA, which is a public organization in Denmark that manages business registration and compliance. It also runs a multi agency online platform called Word, where companies can register, submit filings, and complete regulatory processes digitally. What makes this case interesting is how DBA handled explainability in AI. Instead of trying to fully open up the AI model, which is the black box model over here, and explain every technical detail, they focused on managing the system around it. They clearly defined the purpose of the AI, carefully selected and reviewed the training data, and ensured that humans remained involved in decision making. So for DBA, explainability was not about simplifying the algorithm itself. It was about setting clear boundaries, strong oversight, and accountability structures around the case. Why DBA is a strong example. Firstly, DBA is a public sector regulator and not a private company experimenting with AI. It oversees business registrations, fraud detection, and compliance. As a government authority, they operate under strict legal and transparency requirements. For instance, if an AI system flags a company for suspicious activity, that decision must be justified. They cannot simply say the system predicted it. There has to be accountability. That's why, in their approach, the AI supports caseworkers. It does not replace them. The humans review the outputs, make the final decisions, and take responsibility. Since this is a legally sensitive and high stakes environment, DBA shows that explainable AI is possible even under strict accountability standards. Now, briefly, we'll talk about how DBA applied this framework. They focused on managing the entire AI system, all the six dimensions together, namely model, goals, training data, input and output, and the operating environment together and not in isolation. The three pillars where it focused specifically upon was first, predictability. They ensured predictability. The system behaved consistently within defined conditions. Secondly, human control. They maintained that the system is uncertain and human reviews the case. Final responsibility should always remain with the people. Thirdly, risk containment. The limited risk. The AI systems were given narrow, clearly defined tasks. They avoided uncontrolled self learning and kept the system within clear boundaries. So, overall, their approach shows that explainability can be achieved through governance, structured oversight, and human accountability, even when the model itself is complex. With this, I'll now hand it over to Siddharth, who will talk about the specific projects DBA has implemented. The next slides will show some concrete examples of these applications.
Hi everyone, my name is Siddharth and continuing with the presentation, I will present two AI application examples within Danish Business Authority and explain how human in the loop ensures accountability and responsible AI usage. Let's begin with the project 1, company registration system. At Danish Business Authority, one of the key responsibilities is registering new business companies in Denmark. An AI system here could be used to detect potentially fraudulent companies during the registration process. This is considered a high risk application because it has a legal and a regulatory impact. If a legitimate company is wrongly flagged, it would delay in business operations. On the other hand, if a fraudulent company is approved, it could lead to a financial crime or misuse of the system. Because of this high risk nature, the model used must be explainable, such as gradient boosting model. Now, coming back to why explainability is important. When the system flags a company as suspicious, caseworkers must justify the decisions. They need to explain what factors led to the alert, for example, unusual ownership structures, abnormal registration patterns, or inconsistencies in submitted data. In high-risk public sector decision, transparency is essential because decisions must be legally defensible. Now let's move to the project 2, that is a signature detection system. This system checks whether the submitted document are signed and authentic. Here the risk level is low, and if the AI incorrectly detects a signature, and if AI incorrectly detects a signature, a human can quickly verify the document visually. The consequences are minor and easily correctable. Because of this low risk, a black box model such as deep neural network is acceptable. Even if the internal reasoning is not fully explainable, the output can be easily validated by humans. So, the key difference between these two projects lies in the risk level and required explainability. Moving on to the second slide, now let's discuss the human in loop and output control at Danish Business Authority. Human in loop act as accountability mechanism. An AI system can provide outputs along with confidence scores. When confidence is low, the case is automatically escalated to a human caseworker. Caseworkers verify results directly before making final decisions. Here's the crucial insight. Humans do not explain the model. Humans explain and take responsibility only for the financial decision. Sorry, for the final decision. This distinction is critical because legal responsibility always remains with the human authority, not the AI system. In the conclusion, within the Danish Business Authority, AI can improve efficiency and detect the risk, but the model choice must match the risk level. High risk systems require explainability, while the low risk systems allow more flexibility. Most importantly, AI supports human judgment. It does not replace it. Thank you.
Okay, so let me discuss the controlling training and input data. Now, DBA has used a large and representative dataset and manually tagged around more than 6,000 documents with the help of domain experts as consultant. This helped ensure the data was accurate and reduce hidden bias in the model. They also checked the limitations of the dataset to avoid wrong conclusions. For example, they made sure the model was not biased towards only certain company sizes. They kept training data and testing data separate, which allowed them to properly evaluate model performance and monitor changes over time, especially when the data pattern got changed over time, which is actually known as the data drifting. Next, about input data, they are more focusing on understanding where the data is coming from and how it affects the output. They validate and pre-process the data to improve the reliability. Even simple steps like correcting the orientation of the uploaded image improved model accuracy significantly. The main idea here is that by carefully controlling training, input and output dataset, even a complex black box AI model can be used safely and reliably. Now about environment boundaries and architecture, DBA has reduced the risk by setting proper environment boundaries for their AI systems. AI failures often happen when systems receive wrong input or operate outside their intended use. For example, a signature detection model once identified a toy image as a valid document. So to prevent this, DBA added input filters to check whether the data was appropriate before sending it to the AI system. They also used a modular event-driven architecture. This made results easier to analyze and ensure that any failure stayed limited into one part of the system and not goes beyond that. Uh, Most importantly, AI systems only gave recommendations here. Final decisions were always made by human case workers. Now, DBA intentionally avoided self-learning of the AI systems. Uh, Instead, they are using batch training models which manually tag dataset and handle data and concept drifts. Uh, where real world patterns such as fraud behavior changed over time. Continuous learning systems can produce different outputs for a same input over time, making behavior unpredictable and difficult to explain. Since accountability and legal transparency are very important, DBA accepted a trade-off: less adaptability but greater stability, explainability, and control. So, okay, over to Apoorva now.
Thanks, Gautam. Till now, we have seen why explainable AI matter, the six core elements of an AI agent, and what is the DBA case study, and how does its AI framework work. Now, we will see the key recommendations for explaining the behavior of a black box AI system. The first key recommendation is use of black box and its restriction to areas where the decision is high impact, and secondly should not be used where the law requires the explainability of AI. So black box AI can be used but with human interference so that output cannot be biased. The second is dividing complex business processes into smaller modules which would be controlled by well-defined AI systems so that the developers can have control over the application functionality. Third is we should prefer offline training where we want accountability in AI. And the fourth is there should be continuous dialogue between the technologist, that is data scientist, and the domain experts so that all are well aware of the logic of the AI system and its output. Moving on to the key takeaways, this DBA case proves the first is explainability is designed, it is not extracted, and it can be designed for working on the six elements of an AI agent. Those six elements are model, goal, training data, input data, output data, and environment. Second is black box AI can be safe if it is governed in the right manner. Third is human authority should be there so to make a AI agent responsible and accountable. And the final one is the environment. There should be boundaries, control, and oversight which would enable the trust. So as it is rightly said, explainability is not about opening the black box, it is about controlling the system around it. Over to concluding comments, as we are seeing in the figure, what is a responsible AI decision and how is it surrounded by different layers. So there are six layers by which this responsible AI decision surrounded. First, layer one is model choice. So simple and transparent model can be used for high impact decisions. However, the complex models should be reserved for some cases where human verification is easy. The second layer is human in the loop. So to make AI as responsible and accountable, there should be final authority which should be lies with the human, and especially in the cases like fraud detection, compliance, and legal decisions. Layer 3 is training and control data. So our training data should be unbiased because the biased data would lead to biased decision. And the layer 4 is input. So we should have clear visibility about the data and where is it coming from. Layer 5 is output. So our decision should be paired with the clear rationales and clear performance matrices. Layer 6 is environment and governance. So there should be legal, ethical, and organizational control over the AI system so to make it compliant with the laws. Guys, as we have seen, uh, the six elements of an AI system and what are the different dimensions we should work upon to make AI system as responsible and accountable. So what we require is a shift in thinking. So traditional view talks about explainability of black box and it focus mainly on interpretation of internal model logic. However, this paper talks about the this paper talks about explainability in a different way, and it says that the full model transparency cannot be achieved because it requires trade-off between transparency and accuracy. So there is new perspective which talks about explainability of a model, and it says that explainability must be achieved around the model, not inside it, because it is a system-led capability, not a model feature. Thank you.